Something extraordinary lit up the sky on July 5th, 2025. For just a split second, a bright flash flared across the surface of Saturn, one of the solar system's most enigmatic giants. Captured not by NASA or a billion-dollar observatory, but by a lone amateur astronomer in Virginia named Mario Rana. The image, haunting. A sudden burst of light on the pale golden disk of the ringed planet, silent and surreal. Within hours, the footage ricocheted across astronomy forums, expert networks, and scientific social feeds worldwide. Had Saturn long considered too distant and quiet for such visible drama, just taken a direct hit from a rogue object? And if so, what kind of object slams into a gas giant visible from Earth? This wasn't just another telescope trick. Rana, known for his meticulous data and clear sky captures, had recorded something no one expected, a potential live impact flash on Saturn. But what followed was even stranger. Unlike past Jupiter collisions, where confirmation poured in from all sides this time, there was silence. No second observer. No professional validation. Only the eerie lone signature of that flash. And yet the stakes were enormous. A confirmed impact on Saturn would be a scientific milestone, possibly exposing secrets about its atmosphere, gravity, and role as a celestial gatekeeper. But more than that, it would raise unsettling questions. How often do large bodies strike Saturn unnoticed? Could Earth ever be caught off guard the same way? And what if that flash wasn't an impact at all, but something entirely different? Something we don't yet understand. This wasn't just a case of, did something hit Saturn? It was a case of, what are we missing in the vast darkness between planets, and what might still be coming? As astronomers scrambled to confirm or deny, and software tools parsed every frame, what began as a potential cosmic explosion became something else entirely, a riddle. One that peeled back the curtain on how fragile, fast, and fiercely debated our view of the universe really is. This is the full story behind the flash on Saturn, and why the truth may be more beautiful and more terrifying than anyone expected. When Mario Rana reviewed the frames from his telescope on that calm morning in Virginia, he expected crisp visuals of Saturn's rings, not a brief, concentrated burst of light. Yet at precisely 03:17 a.m. UTC, a luminous flash appeared just above Saturn's equator. It lasted less than half a second. But for trained eyes, that moment spoke volumes. Rana's instinct kicked in. This wasn't a lens flare or pixel glitch. He immediately submitted the raw footage to international astronomy forums, attaching timestamps and atmospheric conditions. Within hours, the Planetary Virtual Observatory and Laboratory, a decentralized network of amateur and professional astronomers, issued a global alert. The request, can anyone else verify this flash? That's where the problem began. No other telescope, amateur or institutional, had been pointed at Saturn in that exact moment. No parallel data, no second capture. The entire case hung on a single source. That's when the software stepped in. DETEKT, an AI-based analysis tool developed to study short-lived planetary light anomalies, began running frame-by-frame diagnostics. The software, first deployed during Jupiter impact events, specializes in distinguishing real cosmic impacts from digital noise. DETEKT has previously verified dozens of real impact flashes on Jupiter, many later confirmed by Hubble and ground-based telescopes. But Saturn, that's a different story. The software flagged Rana's flash as non-repeatable, meaning it couldn't find matching frames across any known satellite or telescope database. It also couldn't rule out light interference or sharpening artifact, since many amateur astronomers like Rana routinely apply contrast filters and clarity boosts to reveal planetary details. Those same enhancements can sometimes create false signals. As the hours ticked by, hopes for confirmation dwindled. Still, the Saturn flash remained a legitimate anomaly. DETEKT didn't classify it as a hoax or tampering, just an unresolved data point, real but unexplained. And that, ironically, made it even more compelling. Among the community, debate erupted. Could a micrometeoroid have briefly burned up in Saturn's upper atmosphere, too small to leave a trace, but large enough to ignite visible light? Or did the ring system itself, known for reflecting solar radiation in unpredictable ways, create a momentary flare mistaken for impact? Even more intriguing, could the flash have originated not from Saturn, but from one of its dozens of moons? Without multi-angle confirmation, triangulation was impossible. And so, for all its clarity, the observation stood in limbo. Not confirmed. Not debunked. Simply suspended, an echo of light against the backdrop of a planet shrouded in mystery. The event underscored how fragile real-time space observation still is. Billions of dollars in orbit, and yet a single telescope on Earth may catch something the world misses. That truth alone sent waves through the scientific community, because if this was an impact, and we missed it, what else is striking our solar system quietly, invisibly? As the buzz around Rana's footage spread, so did the cracks in consensus. Veteran observers, space weather analysts, even planetary scientists began chiming in, but not all agreed on what the flash represented. Some leaned toward the impact theory. Saturn, after all, is not immune to collisions. Statistically, it's estimated that the gas giant is struck by objects larger than 1 kilometer, roughly once every 3,000 years. Smaller objects collide more frequently, but their remnants often vanish within seconds into Saturn's thick, absorbing atmosphere. Could Rana have captured one of those elusive micro-impacts, a brief but powerful atmospheric entry that burned hot fast and left no visual scar? Possibly. But others warned against jumping to conclusions. One prominent planetary physicist argued that the visual signature, while striking, lacked the typical spread or diffusion one would expect from a high-speed impact flash on a gas giant. Instead, she suggested it might be a photometric anomaly caused by sunlight refracting off Saturn's dense ring particles, especially if the camera settings were hypersensitive to contrast. Still, that theory carried its own contradictions. Saturn's ring system, as majestic as it is, tends to scatter light broadly, not in sharp contained pulses. The debate deepened. Another hypothesis took a different angle entirely. Perhaps what Rana saw wasn't Saturn at all, but an Earth orbit satellite flaring just as it passed across the telescope's line of sight. A rare coincidence, yes, but not impossible. Skeptics pointed out the absence of any parallax movement in the video, which would support this theory. Yet this, too, remained speculative. None of the satellite tracking databases showed any known object in that precise trajectory. And then came a darker undercurrent, the psychological and institutional bias against unconfirmed amateur discoveries. Despite the fact that dozens of major celestial events have been first spotted by hobbyists, from cometary fragments crashing into Jupiter to previously unknown near-Earth asteroids, the mainstream response often defaults to doubt. Rana's case reignited a long-standing friction between citizen scientists and official institutions. While agencies like NASA encourage public observation, actual integration of amateur data into peer-reviewed conclusions remains cautious, if not slow. Yet ironically, it's this decentralized web of enthusiasts watching the skies night after night, without funding or formal mandates, that's catching the most unpredictable events. In fact, the software DETEKT itself was born out of this grassroots necessity. It exists because professionals couldn't afford to monitor every planetary body 24/7, while hobbyists could. But perhaps the most compelling aspect of this story is what it reveals about Saturn itself. Unlike Jupiter, our solar system's cosmic vacuum cleaner Saturn remains underobserved. Its atmosphere is less reactive, its ring system more complex, and its role as a cosmic shield far less understood. Some theorists have even speculated that Saturn's rings might deflect or absorb incoming debris before it ever hits the surface, serving as a kind of planetary armor. If so, then what Rana recorded might not have been an object hitting Saturn, but one interacting with the ring field, briefly igniting from friction or compression. But here's the real twist. Whatever it was visible from Earth, meaning its energy output crossed millions of kilometers and broke through the planet's veil of silence. That alone elevates the event from curiosity to significance, because even in the absence of confirmation, it forces us to ask, what's really happening in those outer regions of the solar system? And why do so many of these flashes, impacts, and anomalies go unnoticed or unexplained? The solar system isn't static, it's violent, moving, colliding. And yet we still rely on luck, vigilance, and happenstance to glimpse these cosmic episodes. Rana's flash was just one frame, but in it, we saw not just Saturn, but our own observational limits, and perhaps a warning. In the end, Mario Rana's sighting wasn't confirmed. The flash remained a spectral moment, visible, recorded, shared, but never corroborated. A ghost on the edge of Saturn's storms. Yet what it triggered was more lasting, a full-scale stress test of our global skywatching systems. Within just 24 hours, forums were flooded, satellite logs, checked, signal processing software reconfigured, and new calibration protocols proposed, all sparked by a single video clip from a backyard telescope. And that alone rewrote the rules. It reminded the world that space observation today isn't the exclusive domain of multi-billion-dollar agencies or cryogenically cooled instruments in Earth orbit. In truth, the frontier has shifted. It now includes spare rooms in Virginia, rooftops in Mumbai hillsides in Chile, places where civilians with passion and patience scan the heavens, not for glory, but for the thrill of witnessing the unknown. Rana's fleeting Saturn flash showed that even the most advanced planetary models are only as good as their coverage. Jupiter might be the better documented cosmic impactor, but it's also the better observed one. Saturn, veiled in subtle tones and protected by enigmatic rings, remains largely unreadable. In fact, many experts now argue that if a significant event were to occur on Saturn, say a 5-kilometer object, slamming into its southern pole, we might never know unless luck placed the right lens at the right place at the right moment. And this perhaps is the most sobering takeaway, even in an era of high-precision astrophysics and AI-enhanced detection, the universe can still surprise us. Light travels, but so does ignorance. We miss things, constantly, not because we lack the tools, but because we haven't yet learned where to aim them or how to listen. That's why Rana's video matters regardless of its outcome. It's not just about what was seen, but what was nearly seen. The almost of science. The event that could have been something else. Could have told us something new. Could have forced us to redraw some line in some textbook. And maybe next time it will. Because for all our software and satellites, the sky still belongs to the watchers. To those who stay up past midnight, who squint into the shimmer, who press record when the rest of us are asleep. Saturn may not have been struck that night, but something else happened just as powerful. A moment of collective attention, a spark of cosmic curiosity, a brief alignment of wonder across the globe. So here's the question that remains. If a single person with a telescope can shake the scientific community for 72 hours, what else might we be missing in the silent shadows of the outer planets?